Welcome back. This is HESI Chemistry video number 6, and we're going to be talking about ions. So an ion is simply an atom that has either gained or lost electrons from the neutral form, and so now it has a charge associated with it. If you need to review what a charge on an atom is, it's in video number 4. And so if the number of protons is not equal to the number of electrons, then an atom has either a positive or a negative charge associated with it, and then it's referred to as an ion. If it has an overall positive charge, meaning it has more protons than electrons, then it's called a cation. So here's how to remember that. Cation has the letter T in it, and a T looks like a plus sign, which is a symbol for positive. So a positive ion is called a cation. It gets this way by starting out as a neutral atom and then losing one or more electrons. An anion is the opposite. That's a negative ion. It has two N's in it, N for negative, so that's how to remember that anion is the word for a negative ion, and it gets that way by gaining one or more electrons. So I'm going to show you some examples of what happens when an atom gains or loses an electron, and also how that impacts the size, because that's something that you are going to need to be familiar with. So what I have to start with here are two identical lithium atoms. And I know they're lithium because they have 3 protons, and that means they have the atomic number 3, and atomic number 3 makes it lithium. These also happen to have 3 neutrons in it, which is not important for this discussion. And the neutral atom has 3 electrons because to be neutral, the electrons have to be equal to the protons. So that is a neutral lithium atom. A lithium ion is formed by losing an electron. So we're going to get rid of that electron here. And so now there are 3 protons and 2 electrons. So 2 of the protons are paired and neutralized by an electron, leaving 1 remaining proton, and so that gives this overall ion a charge of +1, and that makes it a positively charged ion, also known as a cation. But what's interesting here, and just because of the way electrons are arranged in the shells around the nucleus, the first 2 electrons go in the inner shell, and then after that, the next 8 go in the next shell out. And so when the lithium loses its 1 electron, this outer shell is now empty, and if it's not holding any electrons, it's basically not there anymore, so we can delete it. And so now you can easily see that the positively charged lithium ion, cation, is quite a bit smaller than the neutral lithium atom. So a similar thing happens with a negative ion, although not for exactly the same reason. So we're going to use fluorine now. So fluorine, these right now both represent neutral fluorine atoms. So we're going to label this one as just F for neutral fluorine. And then this one, it has the 2 electrons in the middle and 7 in the outer shell. But to be the most stable, any ion wants to have a full outer shell of electrons, and full means 8. And we'll talk about that a little bit later in the periodic table video. But for now, just know that fluorine becomes more stable by adding an electron. And when it adds an electron, now the balance is that there is one extra electron compared to the protons, so the overall charge is negative. Now, it didn't obviously get bigger by me adding the electron here, but in reality it does, and I'm gonna show you that real quick. I need to group this so that everything stays together when I make it bigger. So by adding this extra electron here, all of these are negatively charged, every electron. So when they get close to each other, they repel each other a little bit, like the two like sides of a magnet would do. So by adding that extra electron in there, we've actually made this just a little bit bigger because of that repulsion from those electrons. And so compared to the original neutral atom, by adding the electron, an extra electron, the fluorine ion has become a little bit bigger than the neutral fluorine atom. And so the way to remember that is, in the case of a positive ion, going back to the lithium, it has lost one or more electrons to become positive, and by losing those, it becomes smaller than the neutral atom of the same element. So it loses something, it becomes smaller. That should be easy to remember. And then, of course, in the case of the negative, it gains one or more electrons, and that makes it larger than the neutral atom. So gaining makes it bigger, losing makes it smaller. And so you should understand then that if you're comparing a negatively charged ion to the equivalent neutral atom, it's going to be bigger. And if you're comparing a positively charged ion to the equivalent neutral atom, it's going to be smaller.